Hi, and welcome to this video on writing an equation from a written description. Another word for that would be called linear models. So I'm going to give you two different types of word problems, and the one kind of word problem, they'll be giving you information that could be used to create 2 points that would fit that linear model. And when I'm given 2 points today, I'm going to write my equation in slope-intercept form. The other kind of equation possibility is, that's really bad, that you could be given 2 different rates. So something per something else. And then in that case, the easiest way to write those equations would be to write them in standard form. That's better. So you want to be able to decipher what it is that you're given. So let's look at 2 examples. So go ahead and read this example. Pause the video now and read it to yourself. And as you read, you may have noticed that it's giving you information about filling a pool, and it's giving you the number of gallons, and then it's telling you how many minutes have elapsed. And then again, it tells you the number of gallons and the number of minutes that have passed. And then it asks you to write a linear model of the number of gallons, the volume in gallons, as a function of the number of minutes. So what that tells me is I can write an equation because I've been given 2 points. So the first thing I want to do is I want to pull those points out of the word problem and write them off to the side. So the first point they give me is after 5 minutes is 15 gallons. And I know the 5 minutes comes first in my point because I'm writing the equation so that the gallons are a function of the minutes. So that means the gallons will be my y value and the minutes will be my x value. My second point is 30 minutes and there's 90 gallons. So then, that being said, I know I'm going to use y for the gallons, and I'm going to use x for the number of minutes. And now I'm going to find the slope by using the slope formula. So let me get these numbers filled in. So I put y minus y and x minus x. And now 90 minus 15 is 75. And 30 minus 5 is 25. So when I simplify or divide here, I get that the slope of my equation is going to be, I'm going to write over here, is 3. So in label form, remember that's 3, and the numbers up here are gallons, and the numbers on the bottom are minutes. So gallons over minutes means that my label would be 3 gallons per minute, and that's the slope. Now I'm going to erase this here, so if you want to write any of this down, you might want to do that now. So that's cleaned up. 3 gallons per minute. So what I'm going to do to write my equation, now that I know the slope, is I'm going to use y equals mx plus b. And one way to do this would be to use one of the points, like I'm going to use this top point here, in that, and I'm going to plug in everything except for the b. And I can see that when I plug in those values, 15 equals 15 plus b, that means that the y-intercept is 0. So this is an example of what's called direct variation. So the y-intercept is 0, 0. So when I go to write my equation, I write y equals m, which is the slope, x, and I write plus b, but since b is 0, here is my final equation of the line. And maybe you noticed it was direct variation from the very beginning, but this was the word problem I found in our textbook. And if you follow these steps, it would work even if it wasn't. Okay, so read this next example. It's slightly different. So you may have noticed that in this example, they're telling you a total amount you can spend, and they're saying that one type of pick is 35 cents per pick, and the other type of pick is 25 cents per pick. So those are 2 different rates. And because that's the case, you're going to actually set up this equation differently. Now, the way that this example is kind of set up for you is they give you a little graph over here, and that tells me that the nylon picks will be on the x-axis, so that's going to be my x variable, and that the celluloid picks are on the y-axis, so that's my y variable. So that way we're all being consistent. So in this example, I can't just, I can't find this, I'm not going to find the slope in the same way. Instead, I'm going to start by writing an equation in standard form. Because if it's 35 cents per pick, then I can just do 35 cents times x. And if it's 25 cents per the celluloid pick, I can just do 25 cents times y. And when you add those together, when you add if I multiply the number of nylon guitar picks times 35 cents, that's going to give me my total cost for nylon guitar picks. And if I multiply the 25 cents times the number of celluloid guitar picks I want, that's going to give me the total cost for the celluloid guitar picks. When I add them together, that must equal $5 because that's how much I'm going to spend. Now we're going to look at these later and actually make them an inequality, but for now we're going to spend exactly $5. So that being said, I already have my equation. It's done because I have now this can be considered standard form, but if you don't like to have the decimals, you can actually multiply everything by 100, and then you have 35x plus 25y equals 500. And now there's no decimals. And if you wanted to even simplify that further, you could find the common factor here, which is 5, and then I would have 7x plus 5y equals 100, because I divided everything by 5, since 5 was a common factor for all those numbers. So there I've cleaned it up a little bit, and now you have, these are the same equation just written in two different ways. Again, so the 35 cents per pick plus the 25 cents per the other kind of pick, and they add together equal $5, or I could have simplified it to the 7x plus 5y equals 100. What I want to show you is I can find 2 points here that are very simple, the x and y intercept, and I'm going to get the same answer on both sides. So on both sides, I substituted 0 for x so that I can find the y-intercept in both of these equations. And so on the left here, I'm going to divide both sides by the coefficient, and I get y equals 20. So the y-intercept would be 20, 0. Over here, I'm going to divide both sides by 5, and I get 20. So that means I could get 20 of the celluloid picks and 0 of the nylon picks, and that would still be $5. I put that point on the graph on the right. It's red. So now I'm going to, this time I plugged in 0 for y, and I simplified both sides. I'm going to show you that either way, if I divide by 35 cents on both sides, 35 cents on both sides, or divide both sides by 7, over here on the right, I'm still going to get that x is equal to, it's 100 sevenths, which is about 14.3, and 100 sevenths is about 14.3. Now what that tells me is I can't exactly spend $5 on just the nylon picks, which you probably realize because 35 cents doesn't go into 5 evenly. But if I was going to put that point on the graph, it would be like here-ish. Okay? So then that would mean my line would look like, kind of like that. And then to find different possibilities, I would go through, and I already know one would be 0, 20. And then I would just try plugging in different values for x and solving for y to see which ones are going to give me a whole number. Through checking, I know 5, if I try 5 in for the number of nylon picks, 5 times 7 would give me 35. Then 100 minus 35 would be 65, and 65 divided by 5 is 13. So another solution would be 5, 13. Also 10 would work. 10 times 7 is 70. 100 minus 70 is 30, divided by 5 is 6. So there's 3 different possibilities of nylon picks and celluloid picks. Nylon picks and celluloid picks, that would work, and this is a 6, not a B. Okay, so I hope that this video was helpful. I know it was very long. Good luck.